Alright folks, today we're working on 6.3a, which is perform operations on functions. This is things like adding and subtracting and multiplying and maybe a little division every once in a while. So that's what we're looking for. So remember yesterday we did function composition. We said f of g of x is the same thing as f of g of x. We just rewrote this a different way. A lot of the times as you come across these notes, and I would copy these notes down right now, you're going to have a different way to rewrite them that's going to make it a simpler operation. So we have to figure out what it's asking, and then we can rewrite it, and then it's almost a trivial task. So for this function, f of x is going to be 2x squared minus 5, g of x is going to be x minus 1, and h of x is equal to the square root of x minus 1. So just as a refresher, let's name the parent functions of each of these. I know this is a squared, so it's a quadratic, which would make a U shape if we were to graph it. U, not a V, nice U. I know this is a linear function, it's just an x to no power, so this is a linear, which would make a nice straight line if we were to graph this. And then h is a square root, yes, so it's going to make a kind of a curve off to the right if we're going to graph this. It's a good list of all our functions we have so far. So we're not going to be graphing in this, I just thought it would be a good review to talk about some of these things. Alright, so example 1, f plus g of 0. So we're going to say f plus g, and then again, of course, this is of 0 is how we would say this. So it looks like to me we're adding f and g together and then evaluating it at 0. If you also wanted to, you could also just say this is equal to f of 0 plus g of 0. So same number for each f and g functions, and you're just adding them. So whichever way you want to do, I'm just going to do each of these individual ones. I'm going to evaluate first and then add them together, and then I'll see what happens. So I know f of 0 is 2 times 0 squared minus 5. So exponents first, 0 squared is 0, multiply by 2 gives us 0. So we get 0 minus 5, which is negative 5. G of 0 is, let's see, 0 minus 1, which is negative 1. So if I'm trying to find f plus g, all of 0, I can just say that's the same thing as negative 5 plus negative 1, which is just negative 6. It worked out. We didn't have any numbers or variables left over. Woohoo! Okay, example 2. So in example 2, we have f multiplied by g all of x. Now I don't know if you remember, but from yesterday, if we have an x and not a number, so if we're left with an x, we're going to have x's in our answer. So this is asking us to multiply f of x times g of x. So I'm going to write f of x down. So I've got 2x squared minus 5, and I'm multiplying that. Let's put this in parentheses since it's the whole thing. So replacing f of x with 2x minus 5, 2x squared minus 5, because that's what f of x is, times g of x, which is x minus 1. So I'm multiplying these two things. So I've got a binomial times a binomial. Remember that we need to distribute here. If we just had negative 5, we would just distribute. If we had 2x squared, we just distribute. So we're just going to distribute twice. 2x squared times x is going to be 2x to the third power. 2x squared times negative 1 is minus 2x squared. Negative 5 times x is minus 5x. And negative 5 times negative 1 is positive 5. And because we're not evaluating, because we just have an x and not a number, we're not going to have any numbers left over. So we can say that this is our final answer, especially as we're written in standard form, which is highest exponent term to next highest to none of them. So this is the correct format. All right, so we just multiply them. So if it says multiply, you just write them out, multiply them. Okay, let's look at the last part. So this says g times h of 10. So we could rewrite this as g of 10 times h of 10, and then I'm going to look at the functions and see if I want to multiply first like we have here and then evaluate, or if I want to evaluate and then multiply. So now I'm looking at it, I'm looking at the square root. I don't want to multiply with the square root. I don't want to multiply this square root. I'd rather just evaluate first and then multiply. So let's just do that. So g of 10 is going to give me g of 10, which is, let's see, 10 minus 1. It's going to give us 9. And then h of 10 is going to be the square root of 10 minus 1, which is the square root of 9, which is 3. We're just looking for the principal root here, not all of them. So we're going to multiply these. So g times h of 10 is 9h of 10, which is
27. So G of H of 10 is 27. Okay, last example problem. 2f of x minus g of x. So this one's not even written in our combined form here. Here it is written independently. And it looks like we're doing just of x, so we'll have x's in our answer. So we're doing 2 times whatever f of x is. F of x is 2x squared minus 5 minus all of g of x. And this is where it's going to catch you guys. So when you're doing g of x, it's like a whole thing all by itself. So make sure you put it in parentheses. So we're subtracting x minus 1. So now that we have just regular variables, we've gotten rid of our function notations, we can just solve this like we normally would. So we're going to multiply with these before, and then multiply with these as well. We've got a negative 1 out here before we try to combine the like terms. So 2 times 2x is going to be 4x, 2 times 2x squared is going to be 4x squared. 2 times negative 5 is negative 10. Excuse me. Negative 1 times x is negative x, and negative 1 times negative 1 is positive 1. So I've got some x squareds, I've got some x's, and I've got some numbers. So I'm just going to write my x squared terms first, 4x squared, minus x, and then negative 10 plus 1 is negative 9. So that says negative 2 f of x minus g of x is 4x squared minus x minus 9. Alright folks, come get your practice sheet, and we'll get going.